So this is the second breakout board I made. I've only made these two so far. I was waiting on parts to make the rest. I ordered 300 potentiometers. Just look at this. This is going to allow me to solder on adjustable brightness onto every single board I do. All the LEDs nice and just turn the thing, which is good because then you can put different voltages through them and adjust the resistance to have a set current. $15. $15 for all of that. Thanks, China, I guess. I do hope no slave labor was used in the making of those. Based on the price, I'm guessing it probably was, like half of everything that comes out of China, but I can't control that. I would pay more if it cost more, but let's keep politics out of this. So, using some of the potentiometers from SparkFun, I basically just broke them out onto a board. Because these will fit in a breadboard, just like the buttons, but the thing is, they're very wiggly. You can put them in a breadboard, you gotta squeeze them in, and then you have to press them down in a certain way to turn them, but now they're just on wood, and you can set it down. You don't even have to hold the wood, just have it on the table and turn them. And they all face the same way. I didn't do any fancy wiring here. It's literally just 3 potentiometers mounted. They have 3 pins, here's 3 pins, there's not even a circuit diagram. Because there's too many ways to use these. You can hook them up across for a fixed value resistor, 10K. You can hook them up with 2 pins or 2 pins on either side for a variable resistor, and which side you hook it on is like, if you turn it up, it could be a higher resistance. If you turn it down, it could be a higher resistance. So which way is up depends on which way you hook it up, whichever is more useful for your circuit. And then you can hook it up with all 3 pins, and it's a voltage divider. So you put the power across and then use the 3rd pin as your output voltage, assuming you have a non-resistive or highly resistive load, basically one that doesn't create a parallel resistance like we've discussed in the voltage divider videos. But that's all this is. Hopefully it's focusing. It looks pretty good here. So you just hook it up and there you go. Just as a quick demonstration, I have here my multimeter, and these are male to female jumper wires. I usually use the male to male for going in between points on the breadboard, but these, if you can see the male on this side and the female on this side, are used for hooking up the pins on the breakout boards. Now, why didn't I use female headers and just use the same wires I always use? Well, I wanted to, but here's the thing. So here are male headers. They are just metal pins, and there's a bit of plastic housing on them, and there's a little notch here, and you can just take anything you want. I use a pair of wire cutters, it doesn't matter. You just apply a little pressure there, and it snaps off, and you have your header pin nice and easy. On the other hand, you have your female headers. So these are mainly the plastic housing, and inside, see the pins come out the bottom, there are little metal tines inside. That's what makes contact with the pin that goes in it. The problem is these can't be notched the same way because they have to be a certain distance apart. There's a standard distance for all of these. The male are easy. See, you've got the 3 together here, and if I put the females on there, they fit right on because they're all the same standard distance apart. The males are easy because it's just a pin, and they put enough plastic to hold it together, but only enough to hold it together. Whereas the female pins, they have to have enough plastic to fit the pin in there and enough to hold together. So what you end up having to do is cut through one of the holes. So first of all, every time you cut one of these, you lose 1 pin. So that's wasteful. And also, it's messy. The snap-off ones are nice and pretty. They just snap off. But these, I tried sanding them. I tried using wire cutters. They look gross. Now, they do manufacture them in 2, 3, 4, 5, however many clumps. But I didn't want to buy boxes of female headers in sizes of clumps and just have them laying around in case I wanted to solder that many. And what if I changed my mind? If you have separated male header pins, you can just solder them together. If you have the wrong number of females, you want to remove one, you have to cut them all over again. And then if you want to add one, oh, there we go. In order to get 1 single female header, you need to cut on both sides, so you basically spend 3 to get 1. So that is why the male ones. Practicality. It was a lot cheaper and easier to buy some new wires than to lose my sanity. So all we do, this nice and stable breakout board, I'll put 1 header wire on one side and 1 on the other. So this is on the 2 outside pins of a potentiometer. And I'll put them in these traces, and then I will get the wires of my meter here and connect them to the same traces, and we'll measure 10K ohms. And there it is, 10.74 thousand ohms. So 10,740 ohms, roughly. And if I turn it, it doesn't do do anything because we're measuring across. If I move one of the pins to the middle, or move that to the middle pin, now we're reading partial. And if I turn it down, it goes to no resistance. I turn it up, it goes roughly to full resistance. And this is our potentiometer. And if I switch to the other two, basically the other side, now if I turn it down, the resistance goes up. If I turn it up, the resistance goes down. So standard potentiometer. And when you're done, put away your wire, put your breakout board on a shelf. So no time setting up the circuit, no time breaking down the circuit, just throw it on a shelf, get it out when you need it. That's a breakout board. So like I said, I've mounted it. I have 4 screws that are holding it in, that are nutted in. And just like before, I'm using 2 washers on this side to rise the board up as risers. And on this side, only 1. That just turned out to be the correct angle for me. It is angled, you can see. It is angled a little bit. It's shorter in the front because there's only 1 washer there. But it seems to be nice and stable, so I just went with it. The only thing you have to do is make sure that you're not touching anything that's going to cause a short with the washers, because the washers are indeed metal. But this one you can see that the pins are here and the washers are nowhere near them. Back here, what I've done is I've actually soldered the frame of the potentiometer to the PCB. There's no electrical connection here. No electricity flows through there. It's just the metal housing. I soldered it down. That's one thing you can do. You can solder a housing down to a PCB. You're not making a connection. You're just securing it physically. Solder is metal. It's weak metal, but it's metal. So there you go. You know, if you yank on it, it's going to rip off, but don't do that. So that's why these washers don't matter, because that's just the housing. So there we go. Not as pretty as one that's made by a wonderful factory. This one's even got the right angle pins just for fun. But even though it's not pretty, it's mine. They're teaching me how to solder. They're teaching me all kinds of pitfalls about making boards in the first place. They're even teaching me woodworking. And they earned the hardware store a little more profit. So while they go chuckle over their quarterly earnings, I'll be seeing you.